In practice, many of today's AI systems perform best when they are tightly constrained, yet they are often marketed as if broader autonomy were inherently superior. This creates a quiet paradox. As AI tools become more capable, they also become harder to use well, harder to trust, and harder to learn from. The tension is not primarily technical, but conceptual, about what role machines should play in human reasoning rather than how powerful they are. This video examines that tension and clarifies the conditions under which AI supports thinking rather than displacing it without claiming a universal solution. Consider this: if an AI agent can do something, should it? Some AI products seem designed around the premise that the future involves AI doing the thinking while humans simply follow along. This approach might be a fundamentally flawed design choice that makes AI less useful, and it's not just about humans not wanting to be replaced. Instead, an effective AI system should have clearly defined capabilities with explicit boundaries. Users need to understand what the system can do, what it cannot do, and how to guide it effectively. Additionally, humans should be provided with structure that supports rather than replaces their thinking processes. A good system should allow the human to fully understand what is going on and have full control over what happens next. Some AI optimists may disagree, but think about a common UI design, a single chat interface. What capabilities are available? I don't want to tell an agent that a certain product looks good and all of a sudden my credit card has made a large purchase. I also don't want to rant about how I don't like my boss and then find out that the agent took it upon itself to send an angry email on my behalf. Even if we ignore unwanted behavior, how would this agent manage context? It could remember parts of the chat history, but do I want it to remember some personal issue that I sought advice on? Or if I ask for a less complex answer to a topic that I don't care much about, imagine the agent making a note like, "This user strictly prefers very simple answers, and now I wonder why it's only giving me shallow explanations." Working with AI is hard enough already. Not showing system prompts or context to the user is a recipe for chaos. It would drive me insane to constantly ask, "Did you remember that?" And even if it says yes, after a few days, that information might be gone. These scenarios illustrate a deeper principle. Uncertainty breeds frustration. When systems operate as a black box, hiding their instructions, context, and decision-making processes, users cannot effectively collaborate with them. They become passive recipients rather than active directors. This is not merely inconvenient, it represents a fundamental breakdown of the human-AI partnership, largely regardless of how good AI becomes. From an architectural perspective, transparency in system prompts and context management is not optional, it is fundamental. Hidden states and opaque reasoning chains create debugging nightmares and make it nearly impossible to iterate towards reliable behavior. The magical black box approach might demo well, but it fails in production environments where consistency and predictability matter. When designing or evaluating AI systems, several decisions demand careful consideration. Firstly, does the agent replace a process that holds intrinsic value beyond its output? Consider writing. The initial idea is just the beginning. Most value emerges through the process of articulating and refining thoughts. Writing helps explore ideas, develop arguments, and clarify thinking. Delegating this to AI might produce faster results, but eliminates intellectual development that occurs through the struggle. Conversely, grammar checking or formatting holds little inherent value. These are purely mechanical processes where AI assistance makes sense. The key distinction: does the process itself build capability, Or is it merely tedious work towards a goal? Secondly, are mistakes easily identifiable and results verifiable? A mathematical calculation can be checked. A bug in production code, however, might hide for years before manifesting in edge cases that compromise security or crash systems. The difference in verification difficulty should inform how much scrutiny AI outputs receive. Thirdly, how does this system affect cognitive development and mental clarity? Effective systems explain their capabilities and limitations upfront, enabling users to make informed decisions about when and how to engage them. Poorly designed tools create confusion through unpredictable behavior and unstated constraints. Beyond immediate frustration lies a more subtle concern: the long-term impact on intellectual development. Are users building skills and understanding, or are they outsourcing their thinking and atrophying their capabilities? Finally, can the current AI technology reliably solve this specific problem? This is something that is often overlooked. While largely beyond this video's scope, it is worth noting that current AI performs better in relatively stable domains with clear patterns and common answers, rather than in rapidly changing environments requiring novel reasoning. Understanding these limitations helps set appropriate expectations. Consider a practical scenario. Imagine working at a renewable energy company focused on battery research. The team has identified battery longevity as a critical issue and turned to an AI chatbot for improvement suggestions. Initially, the results seem promising. However, as research progresses and context grows, explaining the full situation to the model in each conversation becomes increasingly difficult. Without sufficient context, the AI's suggestions drift away from actual work and goals. Rather than fantasizing about artificial superintelligence solving all problems or blaming users for poor prompting, consider how system design itself might address these challenges. The core issues are: suggestions lack depth and the results are misaligned. Ignoring model limitations, the root cause is insufficient context and imprecise instructions. Theoretically, users could provide better context with each query, but without thoughtful system design, this approach becomes tedious and unreliable. An improved system might work as follows. First, provide the AI with a carefully crafted system prompt that guides its reasoning process specific to our hypothetical renewable energy company. Employees would need to think critically about these instructions. There is no universal right answer, only approaches well suited to specific contexts. Second, separate context management from insight generation through two interfaces. Employees could regularly write brief summaries of their challenges and breakthroughs, not for performance evaluation, but to keep the system informed. An AI agent can process these summaries into a living report that updates with each new input. Both employees and the insight generation chatbot can get access to this report. The chatbot uses it as context, while employees review it to ensure that nothing critical has been missed. The path forward with AI is not about choosing between human and artificial intelligence. It is about designing systems that leverage the strengths of both. Effective AI systems do not hide their workings or operate as inscrutable oracles. They provide clear boundaries, transparent context, and structured ways for humans to guide their operations. This approach requires more from humans, not less. It demands critical thinking about what tasks truly benefit from AI assistance and what processes hold value in their execution, not just in their output. It requires vigilance about cognitive development and intellectual engagement. Perhaps most importantly, it demands that humans remain active participants in the process rather than passive consumers of AI-generated results.